data are appreciated and communicated if they are arranged, organized, and presented in a clear and concise manner. Good presentation requires designing a table that can be read easily and quickly. So table and graphs are common tools that help readers to better understand the test. Results that are conveyed to concern a group like teachers, students, parents, administrators, or even the researchers, which can be used as basis in developing programs to improve the. So now let us take a look at this table 7.1. Table 7.1 indicates and that is considered a group of raw scores recorded from a summative test administered to 100 college students at the School of Teachers Education. Now, how do we organize and present ungroup data through tables? So as you can see in table 7.1, the test scores presented as a simple list of raw scores. Raw scores are easy to get because are scores that obtained from administering a test, a questionnaire, or any inventory rating scale to measure knowledge, skills, or other attributes of the interest. So as you can see, the arrangement of the scores on this table are not organized or they do not look interesting nor meaningful. So table 7.2, as you can see, they are now arranged from lowest to highest. So table 7.2 shows a simple frequency distribution that shows ordered arrangement of scores, which is better than the random arrangement of row scores in table 7.1. The listing of scores can be in descending or ascending order. So we must create this table by simply tallying the scores. So there is no grouping of scores, but recording of frequency is the single test scores. So with this table, we will know what is the highest and the lowest scores is the frequency, and the present columns give more specific information on the number and percentage of the students who got a specific test scores. So table 7.1 shows doesn't provide, but moreover, we can roughly estimate the concentration of scores with this frequency table. The cumulative in the last column, as you can see, it calculates the percentage of the cumulative frequency below a certain score in that data set. So for example, in the 6th row, as you can see, the test scores of 35 has a corresponding cumulative percentage of 13, and that means that 13% of the class obtained a score below 35. So conversely, we can also that 87% of the scores were above 35. So as you can see in table 7.2 is more informative than table 7.1, but may still find the presented data lengthy. So now, let us try to look at table 7.3 to be discussed by Mae Montes.
Okay, what is frequency distribution of group test scores? The frequency distribution of the group test scores is a frequency distribution where the classes are a range of possible values. Another way of arranging data is by grouping the observations into intervals and tabulating the frequencies for each interval. Okay, kindly look at the table 7.3. As you can see in the table, there are columns, the class interval, the midpoint or X, the frequency or F, the cumulative frequency, the CF, and the cumulative percentage. Okay, the class intervals are usually given just like the table 7.2. So our class interval here is 12. It's because gitungan na siya. Now, paano naman siya gitunga? By solving the size of class interval. So in the table, our class interval is 5. So how do we get 5? By solving the formula of I equals H minus L over C, where I is the size of the class intervals, the H is the highest test score, the L is the lowest test score, and the C is the number of classes. Okay, for example, 79 minus 21 equals 58, and then 58 divided by 12 equals 4.8, or rounded up to 5. Okay, now we're done in the class interval, and let's move on to the midpoint, or X. So these are connotes of middlemost score, which is halfway between the exact limits of the intervals. This is often used for estimating the average value for in each class. So the formula is the class midpoint, or X, equals lower limit plus upper limit over 2. In order to get the midpoint, we use the formula class midpoint X equals lower limit plus upper limit. So for example, in class interval, the 20 minus 24, so X equals 20 plus 24 equals 44, and then 44 divided by 2 equals 22. So our midpoint is 22. So same process ang yapon na himon into other class intervals and getting the midpoint. Okay, next is the frequency. So the frequency are the numbers of data values in the categories of a frequency distribution. It is the number of times an observation or a particular value appears in the data. Moving on to the cumulative frequency, or the CF, is the sum of the frequencies of a given class all previous classes. So the cumulative frequency of the class equals the sample size. So the formula is F plus next F equals total. Okay, next column is the cumulative frequency. So for example, in class interval 20 minus 24, the frequency is 1. Since walay number nakasunod sa iya, we will just put the number 1, the next 1 plus 9 equals 10, and so on and so forth. Kung ang last nga cumulative frequency, it must be equal sa total frequency. And lastly, the cumulative percentage. So this is to calculate the percentage of the cumulative frequency when each interval by the total number of observations, then multiplying it by 100, the last value will always be equal to 100%. So the formula is a cumulative percentage equals F divided by N times 100. And the last column is the cumulative percentage. So in getting the cumulative percentage is we should use the formula F divided by N times 100. Cumulative frequency divided by the total resultant frequency, which is 100, then multiplied by 100 is equals to 1.
So how do we present test data graphically? So it says that a picture is a word of 1,000 words. So sa isa ka picture daw is daghan na kayog meaning nga ma-describe through words. And also it says that a graph can be worth 100 or 1,000 numbers. So sa isa ka graph is daghan siyag numbers or daghan siyag mga formula nga naka-combine. So the use of tables may not be enough to give a clear picture of the properties of a group of test scores. If numbers presented in the tables are transformed into visual models and the reader becomes more interested in reading the material. So, more on kung visual ka, makatch din nimo ang attention sa mga readers. Consequently, understanding of the information can problems or discussions is facilitated. Graphs are very useful for the comparison of test results of different groups of examinees. So, graph daw is the best example sa pag-compare sa mga result. So, there are many types of graphs, but the more common methods of the graphing a frequency distribution are the following nga among ihatag. So, first is histogram. So, unsa nga ba ang histogram? A histogram is a type of graph appropriate for quantitative data such as test scores. So, histogram is one of the best example sa mga graph. So this graph consists of columns. Each base has a base that represents one class interval and its heights represent the number of observation or simply the frequency in that class interval. So there are also statistical software that are available to help construct histograms and other form of graphs. So sa mga online and sa paggamit o computer, there are also some examples of histograms. More important than longhand procedures in constructing histograms is how to call information from the graph. So this is the example of histogram. The graph was automatically generated with the use of statistical software. In this case, Statistical Package of Social Sciences or SPSS was used. Basic steps in SPSS application including the following. So step 1, open the data editor window. It is understood that the data has already been entered into data editor following the data entry process. The assumption here is that you already know the basics of entering data into a statistical program. And then sa step 2 on the menu bar, click Analyze, then go to Descriptive Statistics, then to Frequencies. This brings up the frequencies dialog box as seen below. So parehaan ng picture nga naay ning gawas nga duha ka box. So the process of that are file, edit, data, transform, analyze, and then graphs. And then sa step 3 na ta. To make a histogram, do the following steps. So first, open the data editor. On the menu bar, click the graphs, legacy, dialogues, then histogram. Then also, i-click nimo ang OK. And after you have clicked OK, the desired histogram will automatically be shown. The same process will be followed in generating other types of graphs. You may also try to organize the data using your knowledge in Excel. The following web references can be used for those who have never used SPSS. So naay link diha nga pwede nimo magamit inig maghimo kag histogram. And what is frequency polygon? It's a line graph of class frequency plotted against class midpoint. It can be obtained by joining the midpoints of the tops of the rectangles in the histogram. Histogram is a graphical representation that organizes a group of data points into user-specific ranges. Frequency polygon also, this is also used for quantitative data and it is one of the most commonly used methods in presenting test scores. So this is the example of frequency polygon, figure 7.2. So number 1, locate the midpoint on the top of each bar. Bear in mind that the height of each bar represents the frequency in each class intervals. Number 2, draw a line to connect all the midpoints in consecutive order. And number 3, the line graph is an estimate of the frequency polygon of the test scores. So this is the figure 7.3, frequency polygon of test scores students. So the midpoint of the class intervals are used to plot the points. The midpoints will be the x values and y will be the respective frequencies in each class interval. So what is cumulative frequency polygon? This graph is quite different from a frequency polygon because the cumulative frequencies are plotted. In addition, you plot the point above the exact limits of the interval. As such, a cumulative polygon gives a picture of the number of observations that fall below a certain score, instead of the frequency within a class interval. Figure 7.3.1, Cumulative Frequency Polygon of Test Score of College Students. Remember, cumulative percentage polygon is more useful when there is more than one frequency distribution with an equal number of observations, while cumulative frequency polygon are useful to obtain a number of summary measures, the graph display, or give curves.
Bar graph. What is bar graph? This graph is often used to present frequencies and categories of qualitative variable. A bar chart or bar graph is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values that they represent. The bars can be plotted vertically or horizontally. There are three types of bar graph: simple graph, horizontal graph, and double graph. As you can see, the graph are different. What is simple graph? A simple bar chart is used to represent data involving only one variable classified on a spatial, quantitative, or temporal basis. Next is horizontal graph. A horizontal bar chart is a graph in the form of rectangular bars. The bars chart is a little indicates which data is represented. Last is the double graph. A double bar graph is a bar graph that displays two sets of data. Next, we move on the box whisker plot, defined as a graphical method of displaying variation of data. Box whisker plots are very effective and easy to read as they can summarize data from multiple sources and display the results in a single group. So this is the box and whisker plots on the test score of the college students. For example, the data on the test scores of 100 college students produced this image using the box plot approach. The whisker are the lines that extended from either the top side or lower side of the box. This whisker represents the range from the bottom and the top of 25% data values excluding outliers. Outliers is the number outside the whisker. For example, if you want to exempt students from a final examination, the outliers at the top will be indicate who can be exempted at the same time. Those other side might need more attention and assistance to perform in the class. Next, we move on the last graph, the pie graph. It displays data information statistic that easy to read in like and pie slice format with varying slice size, telling you how much of one data element exists. For example, in a class of 100 students, results were categorized according to different levels, which shown that 10 students 10% score above average, 40 students 40% average, 30 students 30% below average, and 2 to 0 20% is poor. Presentation of the distribution of the test score. 10% of 360 degree is 36 degree. 40% of 360 degree is 144 degree. 30% of 360 degree is 108 degree. 20% of 360 degree is 72 degree. Total of 360 degree.
Good day everyone, my task today is all about what graph is best and what are the variations on the shapes of frequency distributions. So first is what graph is best. So no one can give a definite answer to this question. We cannot say what is best. The histogram is the easiest in many cases of quantitative data, but it may not be appealing if you want to make a comparison of the performance of two or more groups. Bar graphs work well with qualitative data, and if you want to compare the performance of subgroups of examinees, frequency and percentage polygons are useful for the treating quantitative data. The cumulative frequency and percentage polygons are valuable and determining the percentage of a distribution that falls below or above a given point. So, cumulative percentage polygon becomes more useful for the comparison of groups with an equal number because frequencies have been converted into percentage. The box and whisker plots are not very popular because they can be difficult to construct without a statistical software. However, this can provide interesting and salient information to audiences about this data that other graphs cannot provide. In sum, that choice will depend on your purpose and what you want to convey. So next is, What are the variations on the shapes of frequency distributions? As discussed earlier, a frequencies distribution is an arrangement of a set of observations. These observations of the field of education or other sciences are empirical data that illustrate situation in the real world. With the world population reaching 7.6 billion, you can imagine hundreds of possible frequency distributions representing different groups and subgroups. Taken from an infinitely large population, it is reasonable expectations there will be variations in the shapes of frequency distributions. Researchers, scientists, and educators have found that empirical data, when recorded, fit the following shapes of frequency distributions.
Symmetrical distribution. Mean and median are very close to each other, so you can use either of them as a representation of the average. A positively skewed distribution is a distribution that is composed of mostly small observations and a few relatively or extreme large observations. Rectangular distribution is a probability theory and statistic of the continuous uniform distribution. A rectangular distribution is a family of symmetric probability distributions. The distribution describes an experiment wherein the arbitrary outcome experiment that lies between certain Curtis, another way of characterizing frequency distribution is with respect to the number of peaks seen or occurred.